Question 1 tells us that Olivia is asked to multiply two fractions. She starts to model the problem, but has not yet shaded the model. And then it gives us this square. It looks a lot like the birthday cakes we've been dealing with this week. The question says, which multiplication expression could Olivia be modeling? Circle all the correct answers. So it's possible that more than one of these answers is correct. Multiplication expression is a number sentence. That's just what we call it when you get out of second grade. What you want to do is assume that this whole square here is one whole and that it's divided evenly. You can see that right in front of you. This side here is divided into 3 total parts. So each one of those parts is 1/3. The top and bottom are divided into 5 total parts. 1, 2, 3, 4, 5 of them. So one of those parts is worth 1/5. After we've determined what it's divided into, we need to start looking at the possible answers so that we can answer the question. What we talked about in class today was that any of the answers that have fifths and thirds in their denominators are good candidates for correct answers, but not necessarily the right answer. Let's take a look at A. A says 1/3 times 1/5. If you can model that equation on this picture, then it's a correct answer. So what we're going to do is we're going to try and model it. 1/3, I can shade that in here, that's 1/3 of the whole. It's the same birthday cake process. And 1/5 is right here. I can shade 1/5 of the whole right here. Alright, and I'm able to see that one of them is shaded out of 15 total. So A is correct. 1/3 times 1/5 could be modeled with this picture. Now I'm going to back up and see if we can attack the next one. That would be B. Let's get the colors right. Good. B says 1/4 times 1/12. Well, I can already see a problem here. I don't have fourths and twelfths where my model is divided into. So this really just isn't going to work. We can go ahead and say that B is no good. It is not one of the correct answers. It cannot be modeled with this birthday cake. So I'll undo some of that again. And we'll look at C. C says 1/5 times 2/3. So let's try it out. 1/5 times 2/3. Can you model that equation with this picture? There's 1/5. And here's 2/3. One of them. And another one of them. That is 2/3 of the whole colored blue. We see that there are 2 squares, double colored, both red and blue, where they overlap, out of still a total of 15. So the equation 1/5 times 2/3 can be modeled with, what is it, Connie? Olivia. Connie comes later. This one is Olivia's model, and it can show a picture of letter C. D says 7/5 times 1/3. Can you model this equation with this picture? Let's find out. First, I will shade 1/3. And then I need to shade 7/5. I could shade 5/5. That would be the whole thing. But there is not a picture provided to model more than 1. 7/5 is an improper fraction that would be equal to 1 2/5. You can't show that with the picture that they have here. So even though the denominators match, it's still not a correct answer. D is no good because 7/5 is greater than 1, and we don't have a picture of that here. The final possible answer, back out of this enough that we can start over, would be E. E says 3/5 times 1/3, and we're going to try and model that with what we've got in front of us. There's 1/3, and here's 3/5. One of them, two of them, three of them. 3/5 are shaded red. We can see that 3 of the squares are double colored. They're both blue and red. They overlap out of a total of 15 parts. And for the first time, we can reduce or simplify it. If we divide both the top and bottom by 3, we get 1/5. So that can be shown with the model there. So to answer the question, number 1 on the quiz, I don't know why I just wrote that. The answers are A is correct, C is correct, and E is correct.